Theorem 7. Two lines perpendicular to the same plane are parallel, and conversely, if one of two parallel lines is perpendicular to a plane, the other is also. To prove Theorem 7 statement, I have here, this would be our two parallel lines, and these two parallel lines is perpendicular to this plane, as you can see. As Theorem 7 statement, then two lines perpendicular to the same plane are parallel. As you can observe, they are parallel. This line and this line are parallel to each other, and they are perpendicular at this plane or floor. This floor is our given plane, and that would be it. It's so obvious that this line and this line is perpendicular to this plane, right? Theorem 8. If a straight line is parallel to a given plane, it is parallel to the intersection of any plane through it with a given plane. To prove Theorem 8 statement is always true, I have this line 1, our plane M, or line 2 on our plane N. This line 1 would be our given line, plane M, or given plane. And line 2 is our line of intersection of these two planes, which is our plane M and our plane N. Plane N through line 1 with plane M show that line 1 and line 2 lie in a plane N and cannot meet. So that proves that Theorem 8 is always true.
Nalibog ko.
Okay, delete na ganito. Theorem 9. If each of two planes is perpendicular to the same line, they are parallel. And conversely, if one of two parallel planes is perpendicular to a line, the other is also. To prove Theorem 9 is always true, let's consider that plane, this plane, and this line. This plane, line, this plane are good examples for Theorem 9. This plane, and this plane is perpendicular to this line. And that they are parallel to each other, right? As you can see. So that proves that Theorem 9 is always true through this examples. Theorem 10. If a plane is parallel to each of two intersecting lines, it is parallel to the plane of these lines. To prove Theorem 10 is always true, that ceiling and this floor will be our given planes. That ceiling would be our given plane, which is our plane M. This floor will be our plane N. And this line and that line would be our two intersecting lines, which is our given lines. Theorem 10 statements that if a plane is parallel to each of two intersecting lines, it is parallel to the plane of these lines. So therefore, a plane is determined by two intersecting lines, which is that line and that line. So therefore, plane M and plane N cannot meet, and they are parallel. Theorem 11. Through a point not in a plane, there is one and only one plane parallel to this plane. To prove theorem 10, give this plane and a point not on it. Prove that through that point, there is one and only one plane parallel to this plane. Let this line through that point perpendicular to this plane. If through that point there were another plane that is formed parallel to this plane, then that through that point there would be parallel by this line parallel to that point. So that's on. Theorem 12. Through one of two skew lines, there is one and only one plane parallel to the other line. This would be our illustration for Theorem 12. Let this line and this line will be our two skew lines. To prove that through one of the two skew lines, there is one and only one plane parallel to the other line. Let this line be our another line. So as you can see, this line is parallel to this plane. Right? Yeah, that would be all. Thank you. Theorem 13. Through a point outside of each two non-parallel lines, there is one and only one plane parallel to both of these lines. Theorem 13. Through a point, this will be your point, and two non-parallel lines, this line here, your first line, and your second line. There is one and only one plane. This whole door is your plane that is parallel to both of these lines. So that will be the illustration for Theorem 13. Theorem 14. If two intersecting lines in one plane are parallel, respectively, the two intersecting lines in another plane, then the two planes are parallel, and the corresponding angles formed by the lines are equal. Hello. Theorem 14. If two intersecting lines, this will be your line, first line, and this will be your second line. These lines are intersecting lines. If these two intersecting lines are parallel in one plane, this will be your given plane. Respectively, to two intersecting lines, again, these lines that are intersected in another plane, then the corresponding lines formed are equal. So that will be your Theorem 15, 14. Theorem 15. If two straight lines are cut by three parallel planes, the intersected segments on one line are proportional to the corresponding segments on the other. Theorem 15. If two lines, this line here and this line here, are cut by three parallel planes, so your planes, said segments on one line are proportional to the corresponding segments on the other. So that would be the illustration for theorem 15. Theorem 16. Two dihedral angles are equal if their plane angles are equal, and conversely, if two dihedral angles are equal, their plane angles are equal. Two half planes meeting in a common edge is formed dihedral angles. Theorem 16. If two dihedral angles are formed and equal, their plane angles are equal. And conversely, if two dihedral angles are equal, their plane angles are equal. That is the illustration for Theorem 16. Theorem 17. If two planes are mutually perpendicular, and if a line is drawn from a point in one perpendicular to their intersection, then this line is perpendicular to the second plane. Theorem 17. If two planes, this will be your plane 1 and this will be your plane 2, are mutually perpendicular, and if a line is drawn, this line from a point, this point, in one perpendicular to their intersection, then this line is perpendicular to the second line. So that is the illustration for Theorem 17. Theorem 18. If a plane is perpendicular to each of two planes, it is perpendicular to their line of intersection. Theorem 18. If a plane is perpendicular, this plane, to each of these two planes, this will be your plane 1 and your plane 2, then this line, the intersection of these two planes is perpendicular to this plane. That is the illustration for Theorem 18.